Hello everyone, my name is Arpit Narechania and I'm excited to present Data Pilot, a visual data preparation and analysis tool that utilizes data quality and data usage information to help users navigate a large unfamiliar dataset, select a relevant subset, and create a visualization dashboard. Consider a large tabular dataset about people. From this, a digital marketer may select certain records for running marketing campaigns. A business analyst may shortlist some key performance indicators to show in dashboards or reports. A data scientist may slice certain features and records to train machine learning models. This reduction of the size of the dataset is known as subset selection. We should be concerned about it because there might be a lot of missing and incorrect values in the subset. One may not know which attributes are key, important, relevant, and so on. An attribute's values might be skewed. For example, the subset may only have male data points. To understand these challenges more and identify feasible solutions, we conducted a design study with 14 data workers. We asked them about the challenges they faced during data preparation with a focus on subset selection tasks. One outcome of the design study was that data quality is important. Our experts suggested showing users how complete, correct, unbiased their data is, as it may instill feelings of curiosity and care in them. They even suggested designing a visual report card for datasets that can also enable decision makers to enforce data policies. While there are many quality metrics available, based on our experts' feedback, we modeled three of them. First, completeness as the frequency of non-missing values in the data, correctness as the frequency of correct values in the data, and objectivity as the extent that values conform to a target distribution. Note that correctness and objectivity require users to specify their criteria and constraints. We model these metrics at an attribute level as well as a record level and assign a score from 0 to 100. We also compute a heuristic score that is the average of these metrics. A second outcome of the design study was that data usage can also be important. Why? Our experts acknowledged that collaboration during data preparation is tedious and that interactive self-service tools are needed. One expert noted that there are several low-quality data sets just lying around in the data lake. Knowing when, where, and by whom these data are used can help certain tasks, such as data housekeeping. Because usage information is application-specific, we consider a visual data exploration and dashboard building application and define three metrics. In subsets, as the percentage of users that select the attribute or record to be in their subset. In filters, as the percentage of users that applied a filter on that attribute. And in visualizations, as the percentage of users that assigned the attribute to a visual encoding. Like quality, we model these metrics at an attribute level as well as a record level and assign a score from 0 to 100. We also compute an overall score. We present these quality and usage metrics in Data Pilot. Let's see a demo. In this demonstration, I will analyze a dataset of e-commerce transactions and try to select an effective subset that helps me determine meaningful drivers of the company's sales revenue. From the attributes view, I first look up sales price and add it to my subset. Not familiar with other attributes, I hover on them for their description and also inspect their distributions and raw values in the data view. In the process, I selected some more attributes that seemed important. Next, I switch to the review step to review my selected subset. However, I am not entirely confident with my performance. What if my subset has wrong or missing values? I enable Data Pilot's quality information. The data view now highlights data quality issues in red. For example, there are several product names missing and some incorrect country codes. The colored circular glyphs next to each attribute represent an overall quality score from 0 to 100. For example, timestamp in green is of high quality, search engine in red is of low quality, and product name in yellow is of medium quality. Clicking on these glyphs shows a breakdown of the overall quality score into three data quality dimensions: completeness, correctness, and objectivity. For example, search engine has a completeness of only 0.1%, which means most values are actually missing. I am now convinced that there are multiple issues with my subset. To address them, I first deselect search engine. From the quality filters view that is now available, I also utilize the record level correctness filter and remove all incorrect records. The minimap view shows the filtered dataset, and indeed, there are now much fewer records than before. To explore additional attributes, I utilize the attribute level overall quality filter and hide all attributes with an overall quality score below 90. This time, several attributes are filtered out. To help me select more attributes from this smaller list, I enable Datapilot's usage information. The colored glyphs are now split into two halves. The left half still represents overall quality, but the right half now represents an overall usage score for that attribute. Like quality, clicking on these glyphs shows a breakdown of the overall usage scores into three dimensions: usage in subsets, in filters, and in visualizations. For example, city has an in subset score of 87%, which means 87% of prior users performing a similar task selected city in their subsets. Like quality filters view, a usage filters view is also available, but I will instead sort these attributes by overall usage. I see that there are two high-quality attributes, city and purchase value, with medium usage scores. I will also select them. I am now much more satisfied with my subset and can confidently utilize it in different applications, in this case, building a visualization dashboard. I create a few charts by dragging attributes to visual encodings. I will save it and create a few more. We conducted a user study with 36 users and gave them the same task. We divided them into three experimental conditions: baseline, without any quality or usage information; quality only; and Datapilot, with both quality and usage information. We hypothesized that Datapilot users who see both quality and usage information will choose the smallest and most effective subsets with greater success and confidence. Our study analysis validated these. To validate its subset size, we plotted the final count of attributes and records selected by users and colored them by their experimental conditions. Comparing their mean shows that Datapilot users chose the smallest datasets. To validate subset effectiveness, we plotted the percentage of attributes and records with high overall quality and usage scores and low overall quality and usage scores in the subset. For both quality and usage, users selected a higher percentage of attributes and records with high scores, and a lower percentage of attributes and records with low scores. Users self-reported success and confidence on a scale from 1 to 7, where 1 is less and 7 is more. It is interesting to note that this came at a cost of additional user effort. Datapilot's general feedback was positive, with above-average SUS scores. One user said the tool was very powerful to get users to start working on their tasks, and that such information is missing in existing tools. Quality received an overall positive feedback. One user suggested that with this tool, users who don't write code won't ignore data quality aspects. Usage received an overall mixed feedback. While one user category found it to be useful to perform fast and efficient analysis or to avoid repeating past mistakes, another user category had issues trusting the usage information of folks they did not know much about. They felt such information could bias and also hamper their creativity. Our users employed different strategies to select their subsets. Notably, utilizing both quality and usage was quite popular. Interestingly, no user reported relying only on usage information, proving that data quality is still the most important. Some users also relied on their intuitions and preconceptions. Regarding Datapilot's three-step workflow to first subset, then review, and finally visualize the data, our users said it helped them think about what attribute is important, and also to prevent junk data from reaching the chart creation step. We have three high-level takeaways for current tools. Focus on data preparation, not just visual data analysis. Present quality information, always, as it nudges users to pause, reflect, and act on the state of their data. Present usage information, but with caution, as it can reduce exploration of valid data and increase exploitation of popular data. For more information, please read our paper or reach out to us. Thank you.